it's either in a file system locally, HTTP URL, FTP URL. And again, the script is part of the familiar distribution tools, iPaq to make index. And so that just walks through all iPackages, reads a control file out, generates a package file, which looks a lot like the control files concatenated together with some of these like that. Some of the fields like that. And so that's that. And then as we've gotten closer and closer together, we can unbuild devs and rebuild iPackages, which mostly, why do we do this? We do this to strip out command pages and stuff that we don't want to install, or to split those into separate packages. So we'll unbuild devs, and this is also to keep us from having to rebuild everything. Find our Linux Debian file that you want to pull apart, repackage it. Sometimes that install scripts for things that we don't have support for. Right, so that's fine. So let me stop just a second. So just as an example of sort of thing. I just want this or but one of the things that we did, which I also left on my desk. What? Oh, okay.
Couldn't do that during the pause.
Okay, so right, sort of interleaved into the talk in 20 minutes. We built a spin for the iPaq, and I forgot to bring my device. I had it in my hand because I was walking out the door, but that's when I got out the door. Which has sort of everything in one. DJ imager, 2 PC card slots, you can have wireless and more storage. More flash, you can have more storage. An accelerometer for sort of gesture-based things, and audio codec and headset jack because the iPaq doesn't have a large volume input. And so we built a bunch of these things. Actually, we built like 100. So these must be pictures. The camera here is on a rotating barrel so that you can do as a camera, you can do video conferencing mode. And we actually haven't had video conferencing working over IPv6 on this whole thing. But actually, one of the things I did this afternoon was trying to get the latest bits to work. That was weird.
See if your little words on the accelerometer?
Sure.
Gestures?
Okay. So we have in the first version, which is what we're showing here, 2-axis accelerometer in the body of the backpack, as we call it. And so that will give you, it shows you acceleration, but the usual thing it's showing you is gravity. And so you can see if the iPaq, if the whole unit is tipped up this way or up this way. And so, well, one of the things we do is rotate the screen based on that. Also, we have, it's just another input mode. So there's a couple of games that you can sort of roll all around. This is something we did with the Oxygen project at MIT, LTS and AI Lab. And so we provided them with these units, and the students have done interesting things. in one of the seminars I was helping out with, one of the teams did a musical sort of application. So it was they have a positioning system they call crickets, which would give you down sort of a couple of meter, well maybe a meter accuracy of positioning. And then they used the accelerometer, so if you shook it, that was the trigger for the thing to play music. And then they did this choreography where they had 4 students, 4 different sites within the little space that they were doing. And depending on who you were and which space you were, then it played a different note. So then they choreographed it so that only once did everybody crash in the middle. Run around, watching the store on the board, shake it in your spot at the right time. So that was really a cool thing. Just showing as another input mode, if you wanted to do something that was actually sort of more sensible thing is you want to do a single-handed operation and you want to be able to flip through things. So you can flip the iPaq. That would cause it to page forward, page back. When I talked to actually the tablet guys, I'm like, if I'm standing on a T trying to do this thing, I need to be able to do it one hand.
Yeah, how do you manage to get the accelerometers to be gravity sensors? That's quite different.
But so
accelerometer of DC.
I think it's a capacitive sensor. So there's these 2 little arms and they deflect. So they deflect. So gravity is one force that will deflect them. So you can sense that as a DC thing. There is some noise in it, but reasonable accuracy for what we were doing. And so that's how it works. And then for the next bit of the thing, we added, after we did this in the body, we're like, we really want to know which way the camera's oriented. Because on our software application, if the camera's flipped towards you, you have to push a little button to say flip it over. If you flip it back, you have to flip it the other way. Otherwise, you're upside down in one direction. We really want the camera to know which way it is. So in our respin, we added 2 of them, so we have all 3 axes. So you could capture the information, what the orientation of the camera was when you captured pictures. That would give you another sort of interesting.
Was the gentleman on the T with the accelerometer, was he measuring something connected with the train, or was it another project?
Well, the train.
No, I was talking about when I took the T not working. If I'm reading
but
something.
you've got motion and acceleration there.
Right, so then you need to be able to filter out the low motion and really just get the stronger motions, stronger acceleration. So I don't know if that would actually work with the accelerometer, but you might have lots of
I didn't understand if the train was the object that was being measured, or
no.
something else.
No, usually there's not enough acceleration to measure it. It's not that sensitive.
Okay.
But you could measure hand gestures with it. And I think you could probably factor out the train motion from the hand motions. So it was something interesting. It was easy to put into there. And here's lots of details there.
It's so second, you're using that for the page, and that sounds great, and all of a sudden,
that's right.
Like 300 pages and 600 pages, and all of a sudden, the first page again.
Right, another idea was, if you detected falling, that you should seek the disk back to the resting place that you don't hurt anything. I want to spend a few more minutes talking about some of the interesting characteristics of handheld hardware. But that are different from, in terms of more on the kernel side than the application side. Developing for the iPaq. Developing kernel for the iPaq. Okay. So one of the things that is interesting about the iPaq is kind of a pain for us is that there's no BIOS in a separate non-volatile storage that nobody can mess with. So in the PC, you can always reinstall an operating system because there's always the BIOS there to read from disk and floppy and stuff. And well, there is firmware in the iPaq that you're not supposed to mess with, but it won't put Linux. And so the first 256 kilobytes of flash, which is how big an erase block is in the flash that's used in most of the iPads. So I'll talk about flash, but I talked about big chunks that you erase at one time, 256 kilobytes on all about the 1900s. And so we put the bootloader in that, so that's a constant on how big our bootloader is. We add more features, we have to make the code smaller. We still have 30 kilobytes free, I think, as we add file systems and CF and IDE fragmentation of flash, we put a big file system on the rest of flash, and we read the kernel out of there. The bootloader read the kernel out of there and jumps to all this great stuff. And I'll come back to more details about September. This is kind of out of order. Flash temp and flash bar. So the other thing I said about flash was 100,000 erases and the sector stopped erasing. Or stopped programming or something. We haven't ever reached the limit except in one sort of test that we're doing to really stress things. So things that change a lot that you don't need to be non-volatile, we put in DRAM in a RAM-FS file or temp FS, depending on how much control you want to have over it. So flash temp, flash bar, and other things sort of get pushed over into RAM-FS. And one of the things in the back of our mind is it would really be nice to have a union mount file system so you didn't have to do symbolic links to sort of intermingle things that were in RAM-FS and things that were in flash. But we don't have that, so we do careful linking and directories and stuff. We have a very interesting /Linux RC that sets things up so that it can run. CF install. So we can actually dual boot between Pocket PC and Linux. Pocket PC sitting in flash, Linux sitting somewhere else. On some of the models, some of the 3600s, they had twice as much flash as Pocket PC knew how to use. So you could arrange to have Linux in the other half, but we never did that because there was so few people who wanted to do it that way. It wasn't worth the trouble. But the bootloader can talk to PC card, it can talk to IDE, and it can talk to DFAT file system. So it can actually read the image and init RD off of a card and boot Linux from it. So then you can choose with the buttons to choose the external operating system or the internal operating system. So you can actually dual boot the things, but it's a lot more machinery than dual booting on a standard machine. And I did BFAT in the bootloader because both Linux and Pocket PC could talk to it, so it sort of made sense with the first one, and I left it as a challenge for somebody else to do it in So Flash. Flash is one of the most interesting things. One of the most interesting things about handhelds. When you get down into the kernel and the real details of what's going on, because it has this strange characteristics compared to disk, which is what we're used to in most things. Two kinds of flash. When I wrote these slides, actually, we only had NOR flash in iPaq, but now the 1900 NAND flash is what you get in CF cards, MMC cards, secure digital cards, all those other kinds of cards that you put in cameras and stuff. Because it's a lot denser than NOR flash. But it has even more strange characteristics because you have to add error correction because the bits rot, you have to be able to compensate for that. NOR is very well behaved as far as we're concerned. You can, it's an SRAM or ROM-like interface, so you can execute directly out of NOR flash. The only thing is you have to erase these large sectors, and you have to do wear leveling so you don't wear out one sector by rewriting a bunch of times. You only wear out the whole thing. And hopefully you want to last long enough that you never wear it out. And I think for the most part, we're doing that. We haven't had people have to replace their flash drive. NAND flash is denser, which means it's cheaper. So the low end, the Axum and the 1900, which is this guy, they have NAND flash. Cost down. And so they'll need more software than they always from Compaq. Kernel actually supports it. All right, the other thing, Compaq flash is sort of different. It's NAND flash with an IDE sort of controller in front of it. So what software sees looks just like a drive, a disk. What the kernel and other software, as opposed to these kind of flashes where we're talking directly to the hardware. And then so to make flash work without wearing out little bits of it as you update one file and you don't update other files, you can either do it at the block layer below the file system and have a remapping layer that you have your logical blocks map to physical blocks, and you write the same logical block and it ends up going to different physical blocks so that it wraps around and you touch all the blocks before you come back and erase a block. And also handling the matching between sort of 500 kilobyte or so blocks that the file system wants to see and the large blocks that the flash